Hello everyone, in this video we are going to replicate this map of Japan. This is a choropleth map where the colors depend on the number of population of Japanese prefectures. What is new in this video, with respect to the previous one, is that we are setting the range for these colors. So let's see how we can do this with ggplot. First of all, we need to load these packages here. Now, if you watched the previous video, you already know this function getData. Basically, we are downloading from this database the latitude and longitude for the country Japan. So country equal JPN, this is the code for Japan, level equal 1 because we want the data for the prefecture. So I already downloaded this, you can see from here. So if you run for the first time this code, you will download the data. I will run. Now, let's check the class of this object. These are partial polygons data frame. Let's view. This is the data, how the data are stored here. So let's check here the names. And these are all the Japanese prefectures. So now, because we want to plot with ggplot, we need the data to be stored in a data frame. So we are converting this object here into a data frame by using this function here. Let's run this code. Let's view it. And now, as you can see, this is our data frame. This is a people data frame. And basically, we went from data stored in this way to this format. So let's check the class. And as I say, this is a people data frame. It is fine for us to plot with ggplot. So let's check the ID. Basically, these are all the prefectures, but we need to make some adjustment here. For example, Hyogo is written with this accented O, and we want to replace this accented O with just a O. And here, Nagasaki is now written correctly, written Naosaki, so we have to change also this one. So let's start with Hyogo. So here I am extracting the word Hyogo. Hyogo, as you can see, is placed at location number 13. So as you see, 10 is Gunma, 11, 12, 13. So from here, I'm extracting Hyogo. Now, I'm using the str_sub function to extract the third letter. So here, from this object, I'm extracting the third letter. So let's run this one. And here, I extracted this O with the accent. Now, I can use str_replace_all to replace the accented O with just a O in this ID. So let's run this one. Let's check it. And as you can see now, Hyogo is without accent. So now let's correct for Nagasaki. Nagasaki is stored at place number 27. You can see here, Nara is 28. So this Naosaki is 27. So again, I'm extracting here. Now, with this code here, I'm replacing Naosaki because here we have to keep in mind the content of this object, that is Naosaki, with Nagasaki. So let's run this one. Let's check it again. So here we have Nagasaki. So now we can plot. Let me enlarge this one. So this is our first map. And basically here, it's what is important, geom_polygon. This is the data frame, and AES, aesthetics. We map longitude data to the X, latitude data to the Y, by grouping by group, basically this one. and we are filling by ID, by this one. Then here we are setting the title or the underscore equal to keep a fixed ratio for the plot. In void, we are setting a blank void, a blank background, and we are removing the legend. Let's run this code here. And this is our map of Japan. So now we can add the legend. So we can add the names of the prefectures. So let's run this code here. Basically, I add the legend with this code here. The position will be at the bottom. This is just the direction of the legend, in this case horizontal, controlling for the size of the text. And we are removing the title. So let's run this one. And this is our map with the legend. So now let's make the things much more interesting. So we want to make this map as a choropleth map, where the colors will depend on the number of population of the Japanese prefecture. First of all, we need the data for the population. I'm taking this data from Wikipedia, from this page list of Japanese prefectures by population. I will write this link in the description. So let's store the link in this object. And now we read this link with this read underscore HTML. So let's do this. So now this code basically is the same code that we use in the previous video about the winners of Ballon d'Or. So we are extracting all the tables in this Wikipedia page. Let's run this code here. Let's check it. So these are all the tables in that page. So the table we're interested in is the one stored at the index number 1. Let's view it. So it's this one. From this table here, let's take only column 2, prefectures, and column 7, latest census population. Let's view it. So now let's rename these two columns here. Again. We named this column ID the same as this column, but we have a problem here. The issue is that we want to merge this dataset with this one. To match this dataset, we need that the information in the ID column needs to be the same. So as you can see now, we have Aichi here, but we have here Aichi-Ken. So we have to make sure that these names are the same in these two data frames. Another issue that we have here is that population here, you see we have commas. So basically this means that this is, as you can see, this is not a numeric. This column is not a numeric value. So we want to make this as numeric. So let's make this adjustment. Let's start with population. So we can confirm the class. And as you can see, it's not numeric. So what am I going to do now? First of all, I will remove all the commas in this population by using this str underscore remove underscore all. So let's run this code. Now I can convert this column to a numeric value. And as you can see now, this class is numeric. So next adjustment here is to remove all -ken, -fu, -to, the name of the prefectures. Basically, this ken, fu, and to are different administrative level of Japanese prefectures. So let's remove all of them. Let's run and let's check. And as you can see, we don't have that -to or -fu here or -ken. So now we want to remove all this accent. Here I'm using the same code as before. Basically, I'm extracting the word Tokyo. That is stored at number 1. So let's run this one. And from Tokyo, I'm taking the second letter, the O with the accent. Now we can replace in the ID the O with the accent with just O. So let's run this code here. And as you can see, Tokyo, also here, Hyogo or Kyoto, we don't have accent anymore. But still we have here the accent in Osaka and Oita because these are capital O. So I'm doing the same. So I'm selecting Osaka. And from Osaka, I'm taking the first letter, the O with the accent. And now I'm replacing all the O with the accent with just capital O. So we can check here, Osaka and Oita. So as you can see, we have also Japan here. Let's go back to the dataset. Basically, Japan here is the total population. So we don't need this information and I'm going to remove it. Basically, I'm removing the last row. Let's run this code here again. And as you can see, we don't have the last row anymore. So now let's sort the ID in of the dataset. Let's do the same also in this dataset with the latitude and longitude. So it seems that we have the same names, but let's double check. We're going to use all.equal.character to be sure that they are the same name. And this is true. So we know that we can merge these two dataset. And here, we're going to use the merge function. Merge this dataset with latitude and longitude information with the dataset with the population by ID. We are going to use basically this column here and this column here. So let's run this code. Let's view the first 10 entries. So this is Aichi, and this is the population for Aichi. Let's see the last 10 rows. This is Yamanashi Prefecture. This is the population for Yamanashi Prefecture. Now, this code here, I'm just checking that the order, you see we have order here, is correct. So I'm plotting this one. Can take a little bit. Okay, and this confirms that the order is correct. We have a 45 straight line here. So let's plot the, the map of Japan by using the population data. So we are going to make this choropleth map. Here, we are filling, as you can see, by population and not anymore by ID. We are using this scale gradient here, where sky blue will be the low color and slate blue for the high color. And we are going to use these labels equal scales, double colon, comma, because we don't want this scientific notation here. And name equal population, it will be the name of the legend. Here the code, the rest is the same as before. So let's run this one. And this is our choropleth map. You can see here, Tokyo is the most populated area. This is Osaka. This is Nagoya area, Fukuoka, and Hokkaido. Now, this legend here, this is continuous value. What we want to do is that we want to set ranges for this legend here. So let's see how we can do this. First of all, we have to set some breaks. For this, I'm going to use the quantile function. So for the population here, I'm setting this value. So the minimum, the first quantile, the median, the third quantile, and the maximum. So let's run this one. And these are our breaks. Here I'm unnaming the breaks. Basically, I removed these titles here. And now, based on this value, I'm setting the labels. So these will be our ranges. So for the labels, let's run this one. Now, I'm generating a new column in this data set. Be careful here. I'm using this backwards ticks. The reason is because I'm writing the column here, the title for this column with the space. This I'm writing like this because this will be later on automatically the title for our legend. So here I'm using the cut function. So for our column population, this will be the breaks. So the one that we created here. The labels will be our labels here, and here include dot lowest because I want to include the lowest value here. Okay, so let's run this one, and now we are ready to plot. What is new here? Fill equal population range. So we change this one, and again be careful here and here. Then we are going to use this scale underscore color underscore gradient n. For the colors here, we will use this palette of colors. Basically, this one we are selecting 4 colors. I'm going to show you only this one. So these are 4 colors. And basically, the rest is the same. So let's run this one. And this is the map that I showed you at the beginning. See that most populated area is the Tokyo area. Basically, it's this eastern area and the Osaka area here. On the other hand, we see that this uh, western side here is less populated. Okay, I hope this video was useful. Let me know if you use this code to replicate your own country or other countries. And if you enjoyed this video, see you in the next one.